Good morning to all. Today I am going to talk about one-dimensional heat equation. The previously we discussed about one-dimensional wave equation. The equation is dou square y by dou t square equal to alpha square into dou square y by dou x square. So you have to find the maximum power is 4. So we have four conditions: two boundary conditions and two initial conditions. So in one-dimensional heat equation, dou u by dou t equal to alpha square into dou square u by dou x square. So in this problem, the maximum power is 3. So the power of the numerator is 3 because of dou u by dou t, the power is 1. Is equal to dou square u by dou x square, the power is 2. So 2 plus 1, 3. So we have maximum 3 conditions. So two boundary conditions and one initial conditions are there. So the equation is dou u by dou t equal to alpha square into dou square u by dou x square, where alpha square equal to k by rho c. K be the thermal conductivity, rho be the density, and c be the specific heat capacity. Now we have to find u of x comma t. U of x comma t means the temperature distribution at any point x from one end at time t. To solve the equation, we get the possible solutions. So the u of x comma t is equal to a in the e power px plus b in the e power minus px, c in the e power alpha square p square t. And another equation, u of x comma t is equal to a cos px plus b sin px into c in the e power minus alpha square p square t. And also u of x comma t is equal to ax plus b. And the boundary conditions are u of 0 comma t is equal to 0, u of l comma t is equal to 0, and u of x comma 0 equal to f of x. The correct solution is u of x comma t is equal to a cos px plus b sin px, c in the e power minus alpha square p square t. Here c is equal to 1, so the correct solution is u of x comma t is equal to a cos px plus b sin px in the e power minus alpha square p square t. And only one example. A rod of length L has its ends A and B are kept at until steady state conditions prevail. If the temperature at B is reduced suddenly to and kept so while that of A is maintained, find the temperature at a distance x from A at time t. The one-dimensional heat equation is dou u by dou t equal to alpha square into dou square u by dou x square, where alpha square equal to k by rho c. And the conditions are u of 0 is equal to 0, u of L is equal to 100, and u of x comma 0 equal to f of x. Apply the conditions. First of all, to find the f of x are the steady state conditions u of x equal to ax plus b. To substitute the above given values by the equation u of x equal to ax plus b. So first of all, u of 0 is equal to 0. So x is equal to 0 and we get the b value is 0. And substitute the b value, you get only one value, u of x equal to ax. And substitute another conditions, u of L equal to 100, then we get as equal to 100 by L. And substitute the u of x value, 100x by L plus 0. So f of x equal to u of x equal to 100x by L. This is the f of x value and also steady state condition, steady state value. So the boundary and initial conditions are u of 0 comma t is equal to 0, u of L comma t is equal to 100, u of x comma 0 equal to f of x is equal to 100x by L. So the correct solution is a cos px plus b sin px into c in the e power minus alpha square p square t. Apply the condition 1, that is u of 0 comma t is equal to 0. So put x is equal to 0 in the equation number 1. We get a is equal to 0 because of e power minus alpha square p square t is not equal to 0, and also c is not equal to 0. So only the possibility is a is equal to 0. And substitute the same condition, u of L comma t is equal to 0. So put x equal to L. Then we get the answer p is equal to n pi by L. And substitute the p value in the equation number 2. So u of x comma t is equal to b sin n pi x by L into c in the e power minus alpha square n square pi square L square by t square. And here we have two constants bc. So substitute bc is equal to 1 and b1. Therefore, the most general solution is u of x comma t is equal to summation n equal to 1 to infinity bn into sin n pi x by L e power minus alpha square n square pi square L square by t square. And finally substitute the equation number, the condition number 3, that is u of x comma 0 is equal to f of x. For u of x comma 0 equal to f of x means t is equal to 0 in the previous equation and substitute the f of x value. So the answer f of x equal to summation 1 to infinity bn into sin n pi x by L. So is the Fourier sine series. So used by the Bernoulli's formula u v1 minus u dash v2 plus u double dash v3 etc. And finally you get the answer bn equal to 200 by n pi into minus 1 power n. And substitute this value. Therefore u of x comma t is equal to 200 by pi summation minus 1 to infinity minus 1 power n plus 1 by n in the sine of n pi x by L in the e power minus alpha square n square pi square L square by t square. This is the required temperature. Thank you.